Hello, this is the last part of chapter 1, Basic Tools, Unit 4. And this is the quantitative aspect of chemistry and the introduction to the quantitative aspect. As we go, I'm going to share the scale. And here we have. We start with the Unit 4 and its contents. The quantitative aspects in chemistry are studied under Unit 4 for chapter number 1. Basic tools. Measurement. It consists of measurement, uncertainty in measurements, significant figures, round off, conversion factor, dimensional analysis, precision, and accuracy. Now, each of these terms, what they mean and what is the significance of them. Uncertainty in measurements. Many times, whenever you take measurements, you will find that there is some uncertainty. And what that means is that we are not very sure of the last digit of what we are seeing. So in this kind of equipment, you can see that these are all different equipment used to measure volumes of liquids. The first one is a graduated cylinder. Second is a syringe. The third is a stopcock, burette. The fourth is a pipette. And fifth is a volumetric flask. Each of these are accurate by themselves, but the extent to which each of the smallest quantity of amount measured depends upon what we call as the least count of the measurement. Now, in each of these, the measurements are different, and therefore we go and have to find out exactly what the reading is. Sometimes on some equipment, if you measure it up to the mark or prepare it up to the mark, then we know the exact volume that we have prepared as a solution using the volumetric flask, or using a pipette you have withdrawn from the flask. A syringe, of course, has a capacity, and as long as there is no air bubble, we know that we can have an exact volume, again, which can be read up, depending upon the accuracy of what we call as the least count of the syringe that is there, because different types of syringes exist. Because of this uncertainty in the measurement, we need to know the significant figures. That is, all digits in a number that are known with certainty plus the first uncertain digit. That is considered as the significant figures. The more significant digits you have, the better the precision of a measurement. The concept of significant figures applies only to the measurements. The exact values have an unlimited number of significant figures. Now, some of the rules, especially when we have zeros, all non-zero digits are significant. Zeros between two significant figures are themselves significant. Zeros at the beginning of a number are never significant. Zeros at the end of a number are significant if a decimal point is written in the number. That is because it shows the accuracy of the measurement and the capability of the equipment that can measure, because it can measure one more unit, one more digit beyond what the decimal placing says. And that becomes the uncertain figure. So here, zeros between two significant digits are significant. As you can see, we have to include them in this counting of the significant digits. How do we calculate the significant digits? No problem. You start with a number on the extreme left and then move forward, counting 1, 2, 3 to the right. The condition for the number on the last digit on the left is that it must lie between 1 and 9. Once that is done, then you just go move 1, 2, 3, 4 count. And for example, in 1, 0, 0, 2, 3, you will find there are 5 significant figures. Now, if a 0 precedes the first significant figure, then the 0 is not of significance because it indicates a place value. Because once you start decimal point placement, then the 0 in between, still the 0 in between two significant figures is significant. And therefore, you still have a 5 significant digit number. Zeros between the decimal point and the first non-zero digit are not significant. For example, if you have the number 0.0010023, then the two zeros before the digit 1 is not significant. Why? Because it tells us it is a place value, and that means it is a fraction. And what kind of fraction it is? It is a thousandth fraction, and so it is not significant. Significant zeros at the end of our number are significant if they are to the right of the decimal place. And if they are no decimal place is written, then it's not significant. So therefore, you have to look at the number very, very carefully when solving problems to find out whether the number is significant or not, whether the digit 0 is significant or not. Significant figures in calculations. When addition or subtraction is performed, answers are rounded up to the least significant decimal place in the numbers that are used. But remember that only at the end of the problem, when you complete the solution of the problem, you will assign the significant decimal place number value. But even the same applies to the multiplication or division performed. And so again, when you do the multiplication or division, answers are rounded to the number of digits that correspond to the least number of significant figures in any numbers used in the calculation. Now, before I go further to the next one and show you a calculation, there is a rule for rounding off that I've not included on the PowerPoint, but you need to remember this, that if the last digit lies between 0 and 4, then just leave the number as it is. If the last digit is between 6 and 9, then you increase the one digit before that by one digit. Now, this leads us to the question, what happens when the last digit is a 5? When the last digit in a number is 5, you have to think of two places. If the number just before 5 is odd, then you increase it by 1. If the number before 5 is an even number, leave it alone, so that when you add it up, you will not get any extra numbers. And this is a rule that needs to be followed. Otherwise, you will get your answer wrong. Now, for an example for addition and subtraction. So here, the first part you can see is an addition, and you can see the significant figures. The first term has 5 significant figures. The second term has 4 significant figures. When you add them up, you get 6 significant figures. When you subtract it, you get 7 significant figures. So now, once you finish all the subtraction, then only you round it off to the smallest significant figure. And at this stage, the smallest significant figure is 5 significant figures. So what is the rule for the significant rounding off? You see that the last digit is 6, and the number just before 6 is 2. So therefore, we increase the number by 1. And so you get 112.133. However, the number 3 then lies between 0 and 4. And therefore, we can drop it because we do not change it. And so our number becomes 112.13. And that is the correct answer. So you have to be very careful when you calculate it. Same thing, if you multiply 1.827 by 0.762, 1.827 has 4 significant figures. 0.762 has 3 significant figures. And so you report your answer in 3 significant figures when using the calculator. Now we come to what is accuracy and precision. Now, before we come to accuracy and precision, I need to do the conversion factor and the dimensional analysis. First thing is that in conversion factor, you use the conversion factor through every day in your life. For example, if you go to the grocery store, you buy a pound of apples. So on one side, you have a pound, and on the other side, you have the what item you have. So in a pound, there may be 4 apples, 5 apples. So 1 pound equals 4 apples. Just like we say, one day contains 24 hours. So these two are conversion units, and they are equivalent to one another. Therefore, when you divide, for example, one day by 24 hours, the answer will be 1. And if you divide 24 hours by one day, the answer will be 1. So there is always an equivalence such that when you divide the two units, your answer must equal 1. Why is this important? This is important because when you travel abroad, you need to know the equivalence between your money and the international money. Otherwise, you will be taken for a ride. Another thing is this, that when you do calculations in chemistry, you always want to know where you started from and where you are going. Otherwise, you will have no concept of what calculations to perform. Because you need an idea of where you are and where you want to go, we have to introduce our units in the calculation process, as you will see in chapter number 2 and towards the end of this chapter, if there are quantities like that, because we will plug the units and the number towards, and then continue to do the change by using our conversion factor. And that is the significance of having a conversion factor and a dimensional analysis. So dimensional analysis is an analytical mathematical tool which incorporates numbers, the quantitative aspect, with its qualitative aspect, and helps us convert from one unit to the other as we progress along. Now we come to precision versus accuracy. Generally speaking, if you have a set of values that are almost equal to one another, then we call those set of values as precise. In other words, experimental values which lie very close to one another are said to be precise. But accuracy determines how accurate or true your value is when you compare it to a known value. So the difference between accuracy is that it is how close you are to a true given value. Precision is how close you are in between your several measurements. And the best example to understand the difference between the two, precision and accuracy, and to use it correctly, is to look at the dartboard, which is shown to your right of this PowerPoint slide. You see that if I give you 3 dots, and all 3 dots fall on the red circle, then you are precise and accurate because you got the maximum score. However, if your 3 dots fall in a second of that dart board, that is a small arc on the dartboard, then you are precise, but definitely not accurate because they are far away from the red color. On the other hand, if your three dots fall all over the board, then of course you are not precise at all, and neither are you accurate. Now we come to one of the properties of what we studied in Unit 2, properties of matter, and that is density. Now, density, I'm including density here because the unit for density depends upon the state of matter. And the states of matter depend upon the difference in the energy levels of any substance that you use, because that is a classification method based on the amount of energy, which is based on the kinetic molecular theory. So therefore, we see that by definition, density is mass over volume, but the units for a solid are assigned as grams per centimeter cube. Units for liquids, we generally assign them as grams per ml. Units for a gas is grams per liter. But also remember that we just showed in this slide that 1 centimeter cube is equal to 1 ml. And there are two other mathematical expressions that can be derived from the density experiment. And what are they? Volume is equal to mass divided by density, and mass is equal to volume times density. Now, I want to just show you some significance of the relationship between grams per centimeter cube for a solid and grams per ml when using a liquid. Sometimes we get objects that are really irregular shaped, and it's very hard to find the volume of that particular object. And so in order to find out the volume of that particular object, then we have to use a method called as the displacement method. And the displacement method is as the name implies, is very simple to use. You take a graduated cylinder, take some water in it, record the initial volume that you have added into the graduated cylinder, then slowly slide your object, irregularly shaped object, into the graduated cylinder. When you do that, the water level will rise. And so you can measure the final or read out the final volume of the water that contains the unknown object. The difference between the final reading and the initial reading, or what we call as how much was the rise after the introduction of the unknown object, gives us the volume of the object in milliliters. But your object by itself is not a liquid, it is a solid. And therefore, when you report the density of irregularly shaped objects, please remember that being a solid, you must express it, convert it, the milliliter to centimeter cube, and express it. And with that, we are almost come to the end of Unit 4. And you can review the different types of questions that are there from slide number 12 to slide number 18. And each concept I have given what you are reviewing in terms of units and things. And this way, hopefully you will be able to remember and associate with the different units that you have come across. With this, I'm going to stop the share, and the following week, we are going to start our chapter 2.